Hello everyone, and welcome to the next video in this series, learning about integers and helping students be able to visualize this concept. Today we're going to be focusing on the number line. So to start off, I like to use these thinking routines. My favorite one to start off a unit is something that is simple and easy to use, and we call it the See, Think, Wonder routine. The See, Think, Wonder routine I love because it's easy to implement with our students. I'm going to show them a number line here that's got both positive and negative numbers. And all I want my students to do is to really look at it. What do you see? What kind of numbers do you see? The next part, I'm going to have them talk about what they think about what they're looking at. This just allows students to be able to slow down their thinking and really look at something and try to find commonalities with something that they're already familiar with. The wonder part of the routine allows students to spark their curiosity by asking questions of things they may not understand. As a teacher, I don't need to answer all these wonder questions, but they can become a platform for me to be able to springboard off of, to be able to address and investigate some questions that they might have. At the end of the unit, I might decide to come back and look at those wonderings that students had and see if they're able to answer them themselves after studying the unit. I can also use the See, Think, Wonder routine with a number line that's vertical. Sometimes our students will look at a vertical number line and feel like it's something completely new. Giving them that opportunity to really slow down and see what's there, to think about it, and to have those wonderings allows students to be able to connect to what they already know. So as we're talking about the number line, we're really going to want to look at how can we use reasoning and what students already know to help them understand how integers work. So one of the things when we're talking about integers is that it's going to be important to understand that we're talking about this idea of distance from zero. And when we're using the number line, there's going to be two components that we're looking at. We're going to be looking at the direction as well as the magnitude. And so when we look at our number line and we do our See, Think, Wonder, what we want students to pay attention to is that there is direction. Going to the right, we have our positive numbers, and going to the left, we have negative numbers. We also want them to realize that there's magnitude associated with it. So when I look at my 0 here in the middle, and I look at my magnitude, I can see when I move to the right, my 1 is next to it. And when I move to my left, my negative 1 is next to it. And so I'm looking at that distance from the 0, how far away am I? This is going to be important as students work with integers to be able to identify when they look at a scenario, what is their 0 starting point, what is going to represent a positive direction, and what is going to represent a negative direction. So let's take, for example, this idea of an elevator, which we use when we're teaching about integers. When I talk about an elevator, it can go up or it can go down, and then I have my direction, up being that positive integer, down being that negative integer. But I need to make sure that I'm aware of what my 0 is going to be on my number line, and it's going to represent that elevator. So in some cases, my ground level is my 0, and when I go up a floor, I am actually going up 1 floor, and I end up a 1 on my number line. However, sometimes when we're in an elevator, that 1 is our ground 0. And so we need students to understand that in our number line, that 1 is going to be actually our 0. And as we move up floors, even though it might be designated as the second floor, we've actually only gone up 1 level. So making sure that we address with our students, what is the 0 point in our number line? What's that going to represent in our scenario? And to what is going to constitute that positive and negative idea? Another quick example is looking at this idea of golf and how you keep score in golf. When we're looking at that 0 placement on the number line, that's actually going to be what's going to be par. Anything more strikes above par, we're going to get those positive numbers. And if you have strokes that are less than par, we're going to move into that negative number. So identifying what does that 0 represent, what is that positive and negative situation. We can use number lines to also compare numbers, just like we always have. Comparing numbers that associate with the integers follow the same idea. So when we look at a number line and we're going to compare the numbers, we know that the further right that we move along our number line, that number is going to have a greater value. So if I'm looking at a -6 and I'm comparing it to a -3, I can still see that my -3 is further to the right, and so I know that -3 is going to be considered my greater number. So I can use what I already know with comparing numbers with just a positive number line and extending it into that negative number line, keeping the same thought and reasoning. We can do the same thing with addition when we're talking about integers. So I can take this concept that students are familiar with. I can start at 0 with my number line, and I'm going to add 6, and I land on 6, and so that is my answer. Pretty straightforward. I can take that same idea, and what if I'm adding 2 plus 6? Well, I'm going to start at the 2, and I'm going to add 6 more, and I'm going to end up at the 8. And so students are familiar with this idea of working with a number line. We're going to take that concept and that reasoning, and we're going to bring it into working with integers. So if I start off with a -3 and I'm going to add 6, I can use that same reasoning, that same train of thought to help me find the answer. So if I start at -3, which is my starting point, and I'm still going to move forward 6 because I'm adding 6, so I'm moving to the right, I end up at +3. Making really nice connections for our students so they can connect to what they already know without thinking they have to learn something completely new. I can do the same thing with subtraction. So if I'm starting at 6 and I remove 6, I end up at 0, a very nice visual. I can start at a different number, 9, and I can subtract where I don't end up at 0, 9 minus 6, and I end up at 3. So taking that same idea and just transferring it over. Now what happens if I have 3 and I'm going to take 6 away? With the number line, I still follow my same train of thought. I start off at the 3 and I'm going to move back 6 spaces. And I end up at -3. So then that's my answer. So I'm able to connect that idea that I've already had with the number line, that when it's positive, I'm moving to the right, I'm moving up, and when it's negative, I'm moving towards the left. Okay, well, I know you're all thinking about, well, that's easy, and I can understand that, but what happens when we subtract a negative integer? Good question. So how are we going to use the number line to be able to explain this? Well, in the last video, we talked about, So we're talking first about 3 plus a -6. Let's get there first. So if I'm going to add 3 and I'm going to add a -6, that -6 is telling me that I'm going to go to the left. So essentially, I can think of 3 plus -6 being the same as 3 and taking away that 6. Okay, here's the big question. How do we take away a negative integer? Well, we want to tap into what we talked about in the previous 2 videos when we were talking about integers. We want to bring in that idea that we had before, because we know that if we take away a negative, it is going to be the same idea as adding a positive. So we want to use that information to be able to make this equation a little bit easier to digest. So in the previous videos, we talked about having -3, that's where I'm starting from, and I need to subtract -6, but I don't have a -6 to subtract. So what I'm going to do is I'm going to add 3 more negatives to be able to get those -6 that I need. Now I can't just go ahead and add those -6 because then I'm changing the value of my equation. So in order to keep my value the same, I also need to add in those 3 positives, because a negative and a positive are going to cancel each other out. So if I add those 3 negatives, I also have to add those 3 positives to maintain the value. And now I can see that I have 6 negatives that I can take away. And when I take them away, I'm left with a +3. So going back to that reasoning that we had to know that I can change that subtracting a negative to be the same as adding a positive. We also talked about the analogy of using wholes and piles. So if we take that analogy and put it into practice, I have 3 negatives and I have 3 6s, and the equation is telling me that I need to take 6 of those negatives away. How can I take 6 negatives away? I can take them away by adding 6 positives, because then they're going to cancel each other out. And those holes and piles that we talked about in the previous video, I can take those piles and put them over the holes to cancel out and get rid of those -6. So either way that you look at it, getting rid of those -6s, I'm going to have to add a +6. And then I can use what I've used before. I start at the -3 and I work my way 6 up to be able to get +3. When I was working through this, I had this idea and I thought, well, subtraction doesn't always just mean to remove or to get rid of. Subtraction can also mean having a difference between 2 numbers. So I thought I would explore this, and I thought it was fascinating, very interesting. what transpired. So I'd like to share that with you. So we're going to look at the example of 3 minus a negative 6. We're going to look at it though through the lens of looking at a difference. So let's start with 6, and if I were to take away 3, I can think about it as 6 and 3. So I'm going to look at the 3, and I'm going to think how far away is 6 from this 3 to look at the difference. And I can see that I am 3 spots away. So my answer is going to be 3. Well, I can think of it of the same way here as well, as looking at the difference between two numbers. So I have 3 minus a negative 6. So I'm going to start at my negative 6, and I'm going to see how far away am I to be able to get to that 3, which was that starting point. And when I look at the difference between these two places on the number line, I can see that the difference is going to be 9. And if I'm using that logic again of 3, and that taking away the negative 6 is actually like adding 6, I can see that my answer is indeed 9. Interesting. Let's take it a little bit further and see what happens. What if I have a negative 4 and I'm going to take away a negative 2? Well, my thinking is going to be the same. I'm going to start at that negative 2, and I'm going to think, how do I get to that negative 4? And when I look at it, I can see that there's a difference of 2. But in this case, what's very interesting is that when I started at the negative 2, in order to get to the negative 4, I had to move left. And if I move left, then I know that that's a negative direction. And so my answer is going to actually be negative 2. I thought it was fascinating. It's a great way to be able to take something that we've known about subtraction before and be able to apply it to a new situation. Giving students this ability and the opportunity to be able to connect ideas within mathematics is just so beautiful. So I hope you have enjoyed this video showing you how you can use a number line to help your students conceptualize and think about integers.